right, we've done some work with finding the area of an entire circle this year, and this next topic, called area of a sector, is just an extension of that. Remember that anytime we want to find the area of an entire circle, we find it by using the formula area equals pi times r squared. Now, first of all, a sector of a circle is similar in nature to either a piece of pie or a piece of circular pizza. It's just a portion of the circle. So therefore, when finding the area of a sector, what we're really doing is actually finding a fractional part of the area of the entire circle. Now we're going to use ratio of either the central angle to the entire 360 degrees in a circle, or use the ratio that compares the arc length to the entire circumference. And we've done some work with ratios and proportions this year also. All right, so when you're doing this, it's easiest to remember that what you're really dealing with are fractional parts. And we're actually going to write a proportion that compares the part to the whole, either for degrees or for arc length. And we're going to compare that to the part of our circle that represents our sector to the whole circle. So this is kind of an important proportion to keep in mind as we work through these problems. All right, so let's get into this. Number one says find the area of a sector whose central angle contains 60 degrees and whose radius has length 10. Express your answer to the nearest tenth. So since they labeled the 60 degrees for our green little sector here but didn't label the radius, I'm going to start by labeling my diagram, or labeling the radius in that diagram. And then finding the area of a circle is a comfortable, familiar topic for me. I'm going to jump right in and go find the area of that entire circle. I'm going to leave myself a little note here that what I'm really finding is the entire circle. So area equals pi times r squared, or in this case our radius is equal to 10, making the area of our entire circle 100 pi. Now that said, we didn't want to find the area of the entire circle. Rather, we wanted to find just the area that's represented by our green sector. So what we're going to do is figure out what portion of the circle we actually want to determine the area for. So that 60 degrees for our green sector compares to 360 degrees in the whole circle. So again, that's my comparison of the part to the whole. Well, if I express this fraction in simplest form so that I have numbers that are a little bit easier to work with, I can just type into my calculator the fraction 60 divided by 360, and that tells me that this sector represents 1/6 of the entire circle. All right, so part is to whole equals part, the area of my sector, over the area of the whole circle, which I found to be 100 pi. And now, in order to determine x, the area of my sector, I'm simply going to solve my proportion by cross multiplying. So when I go in one direction, I end up with 6 times x. When I go in the other direction, I end up with 100 times 10, 100 times pi times 1, or in other words, 100 pi. To solve this equation, to undo multiplying by 6, I'm going to divide by 6. And since I'm asked to express my area to the nearest tenth, I'm going to do these little about equal signs, and into my calculator I'm going to type in 100 pi divided by 6. And to the nearest tenth, I'm going to round that area, 52.4 square units. All right, the next one is set up a lot the same. It says find the area of the shaded sector of the circle given the fact that the radius is 6 inches and the degree measure of the central angle is 100. Again, we're asked to express our answer to the nearest tenth. So again, I'm going to go ahead and start by finding the area of the entire circle. In this instance, our radius is 6. Making the area of our entire circle 36 pi. But again, I don't want the area of the entire circle, but rather just the area represented by the blue sector. So the degree measure of the central angle is 100 degrees. I'm going to compare that to the degree measure of the entire circle, 360 degrees. And again, if I wanted to, I could use the fraction 100 over 360. I'm going to simplify it so that the numbers I work with when I solve my proportion are just slightly smaller and easier to work with numbers. So as a simplified fraction, that's 5 to 18. And again, I've compared the part to the whole. Now I want to go compare the part of the circle I want to find the area for, x, my blue circle, compared to the area of the whole circle, 36 times pi. So I'm going to go ahead and cross multiply. 18 times x going in one direction, and 5 times 36 times pi going in the other direction. In order to undo multiplying by 18, I'm going to divide both sides by 18. And if you want to, you can multiply that 5 times 36. But I already know, because when I read the question, that I'm going to round this answer to the nearest tenth of a square inch. So rather, I'm just going to go ahead and plug this all into my calculator. 5 times 36 times pi. That whole thing divided by 18. Round that answer to the nearest tenth. It ends up being about 31.4 square inches. Now, those two first examples looked at degree measure of the central angle. The last two examples are going to look at arc length, but our process is going to be exactly the same. We're still going to compare the part of the circle that we're working with to the whole circle, just in a slightly different context. So in number 3, it says find the area of a sector with an arc length of 40 centimeters and a radius of 12 centimeters. Because they don't give us a picture, the very first thing I'm going to do is draw myself a nice size sketch. I'm going to draw the sector in there. It tells us that the arc length of this sector is 40 centimeters. It tells us that the radius of the circle is 12 centimeters. Once again, the very first thing I'm going to do is I'm going to start by finding the area of that entire circle. So in terms of pi, the area of the entire circle, 144 pi square centimeters. Then I have to look at the part that I have. The part of the arc, or part of the circle that I have is 40 centimeters. I want to see how that compares to the entire or the whole distance around the outside of the circle. And another name for distance around the whole outside of the circle is circumference. So circumference is pi times diameter. And I remember that formula by the little mnemonic, cherry, pi is delicious. So there's an easy little way that you can remember that formula. And now I'm going to go substitute in. Circumference is equal to pi times the diameter, which in this case is 24, making the entire circumference 24 pi. All right, so again, I want to go compare my part to the whole. The part of the circumference that I have is 40 centimeters. The entire circumference is 24 pi. If I want, I can use my calculator to simplify this, and I think I will, so that I have slightly easier numbers to work with. So I'm just going to go type in 40 divided by 24. That simplifies to the fraction 5 over 3. The pi was in the denominator, so it's going to stay in the denominator. That equals the part, the x, the area of the sector I want to find, over the entire area, 144 times pi. So now I'm just going to go and once again cross multiply. So going in that direction, I have 3 times pi times x. Going in the opposite direction, I have 5 times 144 times pi. On both sides of the equation, I have a pi. I'm going to divide by it. Multiplied by pi and divided by pi are equals but opposites and will cancel each other out. So 3 times x is equal to 5 times 144. And again, if I'd like to, I can go ahead and get my calculator out and multiply those through, but it's not necessary at this point. In order to undo multiplying by 3, I'm going to divide both sides by 3, making the value of x 5 times 144 divided by 3, or 240 square centimeters. So that question was a little different in the fact that we were dealing with arc length and circumference rather than central angles, but the whole big idea of comparing the part of the circle that you're working with to the entire circle hasn't changed. Okay, last one. Number 4 says to find the area of the sector shown. They tell us that the radius is 4 and the length of the arc is 7.85. And again, they're telling us to express our answer to the nearest tenth. Again, I'm going to start by finding the area of my entire circle. So for this radius of 4, that's going to make the area of the entire circle 16 pi. The part of the circle that I have is that 7.85. We need to compare that to the entire circumference. So the first thing we need to do, or the next thing we need to do, is find that circumference. And again, we want to compare the part to the whole. So the part of the circumference that we have is 7.85. The whole circumference is 8 pi. We want to compare that to the part of the circle whose area we're trying to find over the whole area, 16 pi. Now I could go ahead and cross multiply, but I'm going to be a little bit clever because when I look at the denominators of these fractions, I happen to notice that the 16 pi is double the 8 pi. And what that means is that the numerator of my second fraction, the x, is going to have to be double the 7.85. So again, if you go ahead and cross multiply and solve, you'll end up with the exact same answer. If you don't believe me, you can go ahead and try it. I'm just going to be a little clever and a little smart about how I do this so that I can save myself a little bit of work. So 15.7 square units for the area of our given sector. All right, like always, I want you to take some time and summarize what you've just seen and done in your own words so that it's meaningful and relevant to you. And then once you've done that, see if you can apply what you've learned in the video in order to solve the problems down at the bottom of the next page.